A man walks into a doctor's surgery saying that he needs help because he's addicted to Twitter. The doctor replies he doesn't follow him. This series of videos, we'll do 2 on this regarding different management strategies. We'll keep these rather generic for the time being. Your case studies we'll get to in a moment. I might drop a few little bits and bobs in about them. However, this will be quite a generic one to begin with. We're going to look at the factors that affect flood risk, and also hydrographs, something that students are generally quite scared of. However, they really are very, very straightforward, and hopefully in this video they'll be even more straightforward. So I'd mention your case studies. For river landforms and river characteristics, I want you to use the River Foy, things like Goliath Falls, the meander in Lostwithiel, for example. However, for river flooding, it's far better to use our Boscastle example, the River Valency and the River Jordan. The reason being for that is there's just so much more information out there on the Boscastle floods, far more serious event. Likewise, I'd also want to make sure you're aware that that's also our extreme weather case study as well, that convergent zone rainfall. So make sure we use Boscastle, Valency, Jordan for river flooding, River Foy for landforms. So quick definition of flood to start this video. When a river bursts its banks, it would get you 1 mark. It would be a 2-mark question. Crucially, you also have to include and submerges an area of usually dry land. Here is the Boscastle flood. Hopefully you can see there that 4 Street completely submerged under water. That water would not usually be there, so it categorises as a flood. Likewise, we can see flood damage to these buildings here. These buildings are not usually inundated with water, so this is a flood because the river has burst its banks and submerged an area of usually dry land. Okay, then we're going to go through each of these in turn. These are the human and physical factors that influence the shape of hydrographs. Don't worry too much about hydrographs for the time being. The key thing that we need to be aware of is that these factors can influence whether a river floods or not. And we'll start with area. One of the most complicated ones here is the size of the drainage basin. The larger a drainage basin is, the more water is likely to reach a river through a spell of precipitation. Therefore, you could argue it would be more likely to flood, as there will be more tributaries feeding the single main channel. However, you can also flip that argument and say, well, actually, if it's a larger area, that may well mean that water would take longer to reach the major channel, and therefore actually might make flood risk lower, whereas a smaller, more compact drainage basin, e.g. the River Foy, might actually be more likely to flood, as the water wouldn't be able to escape that area and would quickly reach the river channel. Probably the most complicated one of the whole video is drainage basin size. Come and speak to us if you're not too sure about that one. The next one is slope. This one's really, really straightforward. The steeper a slope is, the faster water will flow down it under the force of gravity, and therefore more likely to flood because water will arrive in the river faster. Furthermore, on a slope, soil will be thinner, generally speaking, because the soil will be washed away by any rainfall due to the faster pace of water. Therefore, if you have thinner soils, it would actually mean that water is less likely to infiltrate into that soil. Very, very important on a slope. I think soil is also going to be a separate point later, but the key thing with slope is to remember that at the higher the angle, the faster water will flow down that angle, and therefore it's more likely to reach the river faster, so there is more chance of a flood. Obviously, the flatter the land, the less likely the water is to reach the river as fast. And the next one, temperature. Right, now this works both ways. Let's imagine an area which has a very high temperature. A very high temperature would therefore mean that the soil is more likely to be baked. That baked soil means that it forms an impermeable surface where water cannot infiltrate into it. Therefore you get more surface runoff. Therefore you can argue the river is more likely to flood, as water will rush over the surface. That can be counter-argued though. In very warm conditions there will be more evaporation prior to any precipitation that takes place, and therefore actually you could argue there will be less chance of flooding because there will be less water in the river due to the amount of evaporation that's taken place. Furthermore, if a higher temperature with more sunlight would mean that plants would photosynthesize more, and therefore actually you could also argue there'll be less water in the drainage basin because there'll be more osmosis from the trees, therefore it's less likely to flood. Let's imagine a very cold area now. A very, very cold area, perhaps a frozen surface, you can argue is very, very likely to flood on the basis that ice would form an impermeable surface. As rainwater falls on the ice, it will not be able to infiltrate beyond that point, and it will run over the surface of that ice straight to the river, potentially increasing the flood risk. Furthermore, a very cold temperature will mean less evaporation has taken place in the run-up to the precipitation event, and therefore again arguably you'd have more chance of flooding because more water is going to reach the river faster. The other one to be aware of, and this has happened in Cornwall before, if we have a snow event and the temperature rises there afterwards, what you can imagine is the snow is almost holding the water in place. As the temperature rises, that snow will melt and the water may well rush the river very, very quickly, and as a result a rising temperature after a snow event, or even after a hail event, or potentially even a sleet event, could mean a greater chance of flooding thereafter. So temperature, an important one to be aware of, works in many, many different ways. The next one is rock type. I really prefer that said geology. Geology, the type of rock there, has a massive, massive bearing. Right, if we have an impermeable bedrock, for example, let's take granite or let's take limestone, water cannot percolate into the bedrock and it will sit on top of that bedrock. That therefore means the soil above that bedrock is more likely to saturate faster. A saturated soil means more surface runoff. More surface runoff means more water reaches the river faster, it's more likely to flood. Whereas if we had a permeable geology, e.g. sandstone, the water will be able to percolate into the bedrock there, meaning there'll be less water trapped in the soil, meaning the soil is less likely to saturate, therefore meaning you should have less surface runoff as more water can infiltrate and percolate, therefore there could be arguably less chance of flood as less of the water reaches the river as fast. Next one is soil. We kind of mentioned this one already, but just an additional point. Soil, a thicker soil means there's more infiltration can take place, there's a greater capacity for water to be stored in the soil, therefore there's less chance of a flood because the water will be in the soil as opposed to in the river, and the river will be less likely to burst its banks. Furthermore, with soil, the opposite would also apply. Obviously, a thinner soil means less capacity for infiltration. It means more chance of saturation. It means more surface runoff. It therefore means that there is more likely to be a river flood. I'm just going to skip the red one because that's the human factor, and hopefully you've identified by this point that all of the greens here are your natural factors. Precipitation type, temperatures are typed again up there, I'm not 100% sure why. Precipitation can have an influence on how likely a flood is to be. Rain, you might consider, would be the obvious way that water would reach a river faster. So yes, if it rains, the soil is more likely to saturate. There could well be more surface runoff. But also just be aware of snow there, that snow can store water, which if it melts very quickly with a rising temperature, that can also be a major cause for river flooding. Right then, land use. Now this one a little bit more complicated. This is your human factor here. This is what human beings have done to influence whether a flood is likely to happen or not. Start with deforestation. Human beings chop down trees for a whole plethora of different reasons, whether it's building houses, whether it's clearing for farming, whatever it might be. So human beings have chopped down trees. As human beings have chopped down trees, it means that there is less interception of rainfall and also less osmosis by the tree. That means more water will reach the soil because there's not being intercepted anymore. Therefore, the soil is more likely to saturate. Therefore, there's more chance of surface runoff. That means water reaches the river faster. That means the river is more likely to burst its banks. So deforestation can be a major cause as to why rivers may flood. I will quickly mention Boscastle here, the River Valencia, River Jordan. There was extensive deforestation of the river banks there, which arguably led to one of the major reasons for the flooding. I will all just quickly go back to some of the green soil. There was very thin soil on the banks of the river, River Valencia particularly. The slope, very, very steep slope into the River Valencia, which acted as a funnel to literally funnel the water straight into it. It's a very small drainage basin area, but unfortunately the precipitation, which was rain, was heavily focused in that area and therefore made it more likely to flood. Urbanisation, the growth of cities. As you urbanise, as you grow cities, you'll have more impermeable surfaces, e.g. tarmacs. You'll also have more drainage to get water away from those areas. Start with the impermeable surfaces. Water will hit that surface. It will not infiltrate. It will run directly off the surface and potentially directly straight into a river. Alternatively, it will be drained away into your sewer system, straight into the river. That can cause a huge amount of water arriving at one single point. So urbanisation leads to impermeable surfaces, increasing surface runoff, and also this direct transfer from the sewages from the sewers directly into the river can also mean more chance for flood. Right, agriculture, the last one here. This obviously also applies to Boscastle, as does urbanisation as well, actually. Agriculture would be the concept, firstly, of clearing trees so you can plant crops. But secondly, what we will use for agriculture is that system of ploughing. Now then, as you plough the land, you essentially leave artificial channels for water to travel in. Sometimes, if you imagine a cornfield, you'll have almost small gullies between each crop of corn. Now, as a result, if those are running downhill, as they were in Boscastle, the water is essentially channeled very quickly down to the river, meaning there's more surface runoff and water reaches the river at a faster pace. Therefore, it's more likely to flood. So those are some of the reasons why flooding can be more or less likely. We'll now start having a little look at hydrographs. Okay, hydrographs. Generally, students find these quite tricky. In terms of the revision sessions I'll do at the end of the year, this is one of the most common questions that comes up. Can we go back over hydrographs? Right, they are very, very straightforward. The clue's in the title. Hydro means water, and you all know what a graph is. When you get any graph question, I don't care if it's in geography, biology, maths, music, it doesn't matter. The first thing to do is always to look at the axis titles. Our x-axis first is time, running across the bottom in hours, and then our y-axis has actually two titles here. Discharge, remember the amount of water the amount of water passing any given point in a river, and also rainfall as well. The reality is hydrographs show two graphs. They show a rainfall graph and also a discharge graph. Now, I'll start with the discharge graph here. It really is as straightforward as this. The black line shows the amount of water in the river at any given time across the x-axis. Now, hopefully what we can all see is between 0 hours and up to around about 2 hours, there is a gradual but steady, slow increase in the amount of water in the river. From around about 2 hours on to 4 hours, there is a rapid increase in the amount of water in the river, reaching its peak discharge at around about, I'd say it's about 4 hours into the 4 hours after the rainfall event has started. From that point on, the amount of water in the river decreases back down to its normal base flow. Okay, the black line simply shows the amount of water in the river, and they've got very nice easy terms. I mean, one of them is called a rising limb. What do you think might be happening in a rising limb? The amount of water rises? Correct. What do you think might happen in a falling limb? I'd go for the amount of water falling, sir. You'd be absolutely correct. And that is all a hydrograph is. It is just so straightforward. That black line just simply shows how much water is in the river at any given time. Nice and straightforward, nice and easy. The tricky bit is they've also added rainfall on here. And you might notice, and you might think it's a bit strange at first, that actually when the rainfall event is happening, the river doesn't really increase that much. And the reason for it is it takes more time for the water to reach the river than simply the rain event. It might have to run over the surface. It might even infiltrate into the soil and then go through as through flow. It might be in the drainage system of a city and then finally pushed into the river. So you don't get a massive rise in the river necessarily when the rainfall occurs. The only other thing you need to be aware of for computer gamers watching this, you'll probably have come across this idea of lag time before. Lag time in terms of river is the point between the highest rainfall, or the peak rainfall, and the highest amount of discharge. In this case it would appear to be around about, what would you say, 3 hours and 35 minutes, 3 hours 45 minutes maybe 3 hours and 30 minutes is meant to be. The idea being there's a difference between the highest amount of rainfall and how high the river reaches. What we need to be aware of is hydrographs are a great way of predicting river flooding, and they can change on the grounds of what human beings do either side of the river, or what we do to the river itself. I'll give you a little example on the next slide. So here are some examples of different hydrographs on the basis of changes in the natural geography surrounding the river. If we start with vegetation, actually in the top right corner, it's probably the easiest one to start with. We've got a red line and a green line. The red line, there is no vegetation. That means there is no interception of rainfall, and as a result rainfall hits the ground, the soil saturates quickly, and you can see after the rainfall, which is occurring, all of them are occurring on the y-axis, the river reacts very quickly. It's actually more likely to flood here on the orange line for vegetation, simply on the basis that the discharge rises very, very quickly. It's more likely to flood. Whereas the same rainfall event for the green line, the line with the forest, is much, much slower to react on the basis that the trees are intercepting and slowing rainfall, and in addition the soil is less likely to become saturated on the basis that so much of the water will be used by osmosis, and the soil itself is actually protected from the trees above. Don't get me wrong, the discharge in the river does rise, but it takes far longer to rise, and the rise is far, far, far less. Hopefully this shows you that trees can massively influence hydrographs, and also massively influence the chances of a flood, with more trees meaning floods less likely to occur. Here again we've got another one. We'll start at the bottom left, valley side steepness. We've got a very steep river valley and a very gentle river valley. Look at the very steep river valley. As soon as the rainfall event occurs, we've got around about the same line to begin with, and then a rapid increase in terms of discharge as water rushes down the sides under the force of gravity quickly into the river. However, the river does very quickly descend down again on the basis that the water has reached the river quickly. The gentle slope, however, it takes much, much, much longer to reach its highest discharge at around about this point, so it's about an hour and a half longer, and it never reaches the same height. As water takes much longer to reach there, it means it's more likely to infiltrate, it's more likely to be absorbed through the process of osmosis by trees or being drunk by livestock perhaps, and as a result it never reaches the same high level of discharge that the steep valley sides do. Soil type as well, an impermeable soil there. I mean, we could say that this was also like in a city, so tarmac for example. There's your rainfall event very quickly. The flashy river is more likely to flash flood because water reaches it very quickly. There's a lack of infiltration, therefore more surface runoff. The river reacts very quickly. The green line, the permeable soil type, quite simply means that the water can infiltrate. It takes much longer to reach the river through flow, for example. The soil is less likely to become saturated as well, and as a result of that, there's less chance of flooding. Now, perhaps the most complicated one is in the top left-hand corner here, a small drainage basin and a large drainage basin. Remember, a small drainage basin is the idea that what a drainage basin is, I should say, it's the land that the river will drain. A smaller drainage basin, you can hopefully see here, means that the river reacts very quickly. However, there isn't a great deal of water really falling in such a small drainage basin, so it increases rapidly and then also very quickly returns back to its normal base flow. A larger river takes a lot longer to react as it takes more time for the water to reach the river. However, because it's such a large area, you might have a bigger reaction on the grounds that more water reaches it, because simply it's a larger area, more rain has fallen in this area. You don't know which one's more likely to flood in this example. However, the idea being the amount of water reaching the river can be changed by the size of that drainage basin. In terms of human impacts here's Boscastle with, you can hopefully see, quite a large impermeable surface area here. The water has hit those streets like 4th Street and the car park, rushed over the surface to the river. Because of that impermeable surface, it means it's more likely to flood. On a hydrograph you see a much steeper discharge graph line, and also probably a much shorter lag time as well. We can also see some evidence of deforestation clearly occurring here as well, meaning there's less interception taking place. So human factors can have a huge influence on the shape of a hydrograph and how likely it is to flood. So just a quick summary of flooding here. A shorter lag time means a river is more likely to flood because water will arrive at the river almost at the same time very quickly, so it's more likely the river will burst its banks. A higher discharge means a river is more likely to flood because simply there will be more water in the river. Just something to come back to in the River Valency case study in the future, lag time and discharge can both, well, lag time can be increased, discharge can be decreased if you plant trees. That will intercept more rainfall. That will also mean water takes longer to reach the surface because the water takes, well, actually it's true, water would take longer to reach the surface because they'll be blocked and held by the trees. And as a result, the soil is less likely to saturate. As a result of that, the river is less likely to flood because water reaches the river slower, and also simply the amount of water to reach the river is decreased. Hydrographs, they are really straightforward, but come and see me down in H7 or H8, whichever room it is, if you are not sure about anything to do with hydrographs.